You have it. Good. Okay. Exam 3, part 1, Thursday at 1:30.
I have to focus it because it's kind of hard to see.
Yeah, I'll focus. Adrian, it's just you. All of us can see. No.
It's me too, Dr. Murray.
Yeah,
I
I
can't see.
can't see either.
No, I was just teasing her. It's not focused. It's trying to psych her out a little. Not that she needs it, but. So this is Zoom and numerical. Okay, those kind of questions. Tom's here. Part 2 on Monday at 2. 2 or 1, whatever works. I want to start at the same time. All of you will start at the same time, Central Time. And this will be on Canvas. And you will have just the amount of time that you have in class. And you will have to, you may have to show work using Math Editor because I need to see your work. All right. So some of you on the practice quiz, you may know how to use a Math Editor, but you didn't show your work using the Math Editor. I just want to make sure that, on the test that you are showing your work. Zoom and video presence required. Okay. And each will be worked, one could be 60 and 40, like the numerical could be 60 and the multiple choice 40, okay? Approximately. And both of those will be added up. And at the end. All right, so you need a scanner. Well, you can use your phone. You've been scanning in assignments. It's the same thing. I'll have a link open and I'll tell you, post it. And then this is Monday at 2. Again, any problems with Monday at 2? 2 to 3 is what you'll need. You'll need to let me know. And then Q&A Thursday at 11 a.m., 11 to 12. Okay. I'll send a meeting invite for Thursday 11 and then again for the exam. All right. And the templates that you need for the numerical work, that'll be posted either today or tomorrow. Okay. And I'll, explain everything again. So first we'll concentrate on the exam this Thursday. And then after that, we'll focus on the exam on Monday. Got it?
Yes.
Okay. All right. Now, we are going to continue with the lecture. Any questions? So don't assume that you know everything. It's some things you learned a long time ago. So you have to go back and review. And there are also some sections from 16 that you need to know. And it's in one of the announcements. Anybody remember? Is that 16.7 through 16.9? Then 17.1 through 17.7. You have to know everything.
Could you say those numbers one more time?
I'm not sure about the 16. Can somebody look that up? I know it's 17.1 through 17.7 for 17. What is it for 16? Anybody?
I think it's 16.7 through 16.9.
Okay, 16.7 through 16.9. I'll write it here.
Yes, that's what it is. It is 16.7 to 16.9 and then 17.1 to 17.7.
Okay, thank you. So 16.7 is acid-base salts. And then, I don't know what 8 is. Oh, that's the structure of the acid. I mean, structure of the acid, how that is related to acid strength. So as you go across, what happens to acidity? As you go down, what happens to acidity? We learned that a long time ago. And 16.9 is Lewis acids and bases. And 17.1, those are all the things that you learned from chapter 17. There are other sections of 17. We did not cover all of that. So 17.1 through 17.7. Go through the lecture notes and rework the problems. Don't assume you know all the steps. Each titration is different, even within the regions, and also comparing weak acid with strong acid. So go through all that. Buffers, how do you calculate the pH of a buffer? What happens when you add acid to a buffer? What happens when you add base to a buffer? And then we learned about KSP, okay? And then how do you find the solubility, molar solubility or gram solubility? And then common ion effect with KSP. And then acid-base salts. How do you classify something as an acetic salt? How do you classify something as a basic salt? You had that for the previous exam, but not everybody, you know, did well. So I'm making you review it again. And also you need it for, you know, doing the weak acid, strong base titration. So that's why the review. So go over that and know how to write the equations for those. How does, you know, a like acetate ion react with water? How does the conjugate base of a weak acid react with water? How does the conjugate acid of a weak base react with water? So you have to know those equations and stuff. And then acid strength, like how do you line them up? If the elements are across the table, how is the acid strength changing if the elements are lined up down a group? Oxyacids, what happens when you increase the oxygen content of the oxyacid? So those are some of the things that we learned in that section. And then Lewis acid bases, how do you classify? What's the difference between a Bronsted acid and a Lewis acid? And then given an equation, how do you identify if something is Bronsted or Lewis or acid or base? Okay, so that kind of sums up what we learned. But you have to review the details. It's not difficult, but you need to put in the time. And this test is not different from any other test, so I think everybody should be able to do just as well, if not better. Got that? You've had a lot of time, and so I want you to do the best. All right, any questions? Okay. So now I'm definitely going on to chapter 18. And then we were thinking about, those of you who came in late, we're thinking about moving our class up to 11 a.m. on Tuesdays, 11 to 1. Let me know if that'll work for you. because some of them are in another hemisphere. Right, Shani? And it's hard for her, she's 2 hours behind.
Yeah, I had to wake up at 7, whatever the time was, 7:30. Tired.
10:30 now.
Yeah, tired.
Order some breakfast, Shani.
I wish I had it like that, Dr. Mary. I wish I had it like that.
Well, Adrian is eating some. Maybe she can share some.
Adrian, share, please.
Yeah, share. Adrian, please. All right. So that's why I want to move the time up to 11 if we can. And we'll see. Okay. All right. So I started talking about this, and then also I have not forgotten about this problem, but I'll come back at the end. Okay, I don't want to take up time right now. Now, also, while we do the problems here, you'll need access to the thermo table that is on Canvas. Thermo table on Canvas under chapter 18. So you will need these numbers. And this is in the appendix of your textbook, appendix A2 or something like that. All right. So now that we have done all of that, let me see what the time is, 10:02. Okay. Ralph, could you pray for us, please?
Yes, ma'am, I can.
For the world and for us.
Yes, ma'am.
Thank you.
Lord, we come before you in this time. Lord, we pray. Thank you for helping us to be here together. Lord, we pray, Jesus, Lord, for what is happening around the world. We pray, Lord, for the protection, and Lord, we pray for the healing, Lord, every nation, Lord, who's been affected in this. I pray that you, Lord, be with us as, Lord, we're about to learn this content, Lord, and give us, Lord, wisdom, understanding, and a presence of mind as we're about to, Lord, learn this material for the exam. I pray that you help us and be with all of us. In Jesus Christ's name, I ask these things. Amen.
Amen. Thank you. All right. So I know nobody cared about entropy the last few days, right? So let me tell you a little bit about what we did before we move on. What does entropy calculate? Anybody?
Disorder.
Disorder, right? So it's the degree of disorder that is calculated. And we were able to calculate the change in entropy. Okay, then let me ask a question. Another question before I write the equation. If you have a solid, of a substance, a liquid, and a gas of the same substance, which one will have the most entropy?
Yes.
Gas.
Yes.
Gas, right? Yes. So that's the degree of disorder there if the gas molecules are more dispersed, right?
Mm-hmm.
And then for physical changes, let's say I go from sodium solid to sodium gas. What's that process called, going from a solid to a gas? Solid to a gas?
Sublimation.
Sublimation, yes. Okay. So if I were to calculate delta S for this process, it's a physical change. Will delta S be positive or negative?
Positive.
Positive. Okay. This is S of product minus S of reactant. All right, S of product minus S of reactant. Everybody doing okay? So when entropy, is entropy increasing or decreasing here? Entropy is increasing, okay? So you need to keep this in mind. And even for a reaction, you should be able to calculate delta S. I'll review that part when we look at an example in this chapter. So that's in essence what we learned. We'll also learn about microstates to understand how mathematically they were able to formulate an equation to calculate delta S. So we just said delta S. This is delta S of change, be it physical or chemical. Okay, change, that is change, okay? I'll remember to write big. Physical or chemical. Delta S is now broken up as delta S of the universe, system, and surroundings. Remember, when you do an experiment in the lab, if you do something in a little beaker, which we always do, or a flask, that's your system. And then the rest of the lab, right, lab, is your surroundings. And the sum of what's happening in the system plus surroundings makes up, what is that called? Universe. Okay. So everything happening in the planets and, you know, all the planets, that's the system. Everything affecting the atmosphere and everything else, that's the surroundings, and it makes up the universe, right? Something like that. But in a smaller sense, the lab is our surroundings. Whatever experimental apparatus you use, that's your system. So the universe is system and surroundings. Why they do this is because, especially for thermodynamics, it involves exchange of heat. And then you have to talk about the degree of randomness, especially going from a solid or a liquid phase to the gas phase. So that's why they have broken it down like this. So in this section, though, you're going to learn about delta S universe, delta S system, and delta S surroundings. So what does that mean? There it is. It's on the next slide, written out nicely for you. So we are focusing only on delta S. We can do the same thing with delta H, okay? But it's more relevant for delta S. So for a reaction to be spontaneous, what must the value be for delta S? The sign.
Positive.
Positive. Okay, that's why we said sodium. I'm going to write on top. It happens naturally under the conditions. So delta S is positive, and we call that spontaneous. And spontaneous, we'll see, is not only dependent on what changes happen with delta S, delta H must also be involved. So we'll see. All right. For now, but this is true all the time. Okay. Spontaneous means delta S universe must be positive, and it's true always. And this is your second law of thermodynamics, if you go back and look at it. Okay, conceptual. Need it for the next exam, right? But delta S is also dependent on delta universe is also dependent on the system and the surroundings. So when is delta S universe positive? Okay, when is delta S universe positive? Well, it's like okay. Let's say this has a value of plus 10. Okay, has a value of plus 10. So delta S then can be plus 3, and delta S surroundings could be plus 7, right? So delta S system and delta S surroundings are positive values. Then delta S universe has to be positive. You see that? Secondly, delta S can be negative system, and delta S surroundings can be positive. For example, I'm going to write it down so it's easy for you to see on the screen. You can introduce your own values. This has to be negative, and this is positive, but this must be plus 10. So I can make this minus 5 plus
15.
15. That's right. Okay. So what's the criterion here? Yeah, if this is negative and that is positive, delta S surroundings must be greater than delta S system. Only then delta S universe will be positive. Understand? Mathematically. Let me grab some white paper. What's the third criterion? If delta S system is positive and delta S surroundings is negative. So this has to be plus 10. But this is negative. So I can use 22 minus 12. So in this case, delta S system, the positive value has to be larger than the one that has the negative value. That's basically it. Okay.
Were we only looking at cases where delta S universe is positive?
Yes. We're trying to look at cases where the reaction or the process is spontaneous. So that's the condition we are looking at. Okay, so if you look at this statement, which is now covered with stuff around it, for a process to be spontaneous, delta S universe must be positive. So under what conditions is this going to be positive? 1, when both are positive. 2, one is negative and the other is positive. But the one with a positive value must be bigger than the one with a negative value. That's all we're looking at. Now, it's on the next page. We're going to look at what are called as isothermal processes. Iso, what does that mean? Same, right? Thermal, temperature. So for an isothermal process, the entropy change of the surroundings is related to the thermal energy change of the system. Okay. Am I skipping a slide? I think so. '39, please. I was like, we skipped something. That's all I could. Isothermal. Same temperature. What do you say when you do something at the same pressure? Isobaric, right? Bar, B-A-R-R, I'm sorry, B-A-R, that's a unit of pressure, so isobaric. Same pressure, okay? So we do our reactions in the lab at the same time, same pressure. At the same pressure, right? Room pressure. So our reactions are isobaric. When you have a pressure cooker at home, that's not at the same pressure as the outside pressure. You're increasing the pressure, but it'll be the same pressure inside the vessel. The reaction being studied, the system is typically very small, right? Your little beaker, 25 ml or even 400 ml compared to the size of the lab. That's very small. So the enthalpy change in the system, delta H system, will have very less impact on the lab, right? Surroundings. In terms of temperature changes. Everybody awake? In terms of temperature changes. Should I have a pop quiz at the end? I think I should start that from next week. Systems that cause no temperature change on the surroundings, okay? So we assume that our little beaker doesn't influence it a whole lot, okay? We can measure how much is lost from your beaker, which is what you did last semester, the calorimeter that you used. But systems that cause no temperature changes on the surroundings are known as what? Isothermal processes or systems. Okay, so they're saying there will be a little bit of a change, but you know, that is going to be very small compared to the large size of the room. Okay, we'll say, oh, it doesn't have any effect, and then you go to PCAM, right, Kevin? And then we'll be measuring that little change that happens. Okay, it's like saying something is insoluble, and then this semester we said, oh, it's not quite insoluble, it is pairingly soluble, right? Okay. Forty. Give me a second. Pages are messed up a little. Okay. Entropy change of the surroundings. So we are now coming up with a relationship. Minus Q of system divided by T. Now remember we were talking about the microstates and you know all of that. All of that mathematically led to this equation where they're relating what is happening in the surroundings with the heat change. Okay. In the system. And then they're saying that's divided by Kelvin temperature. Okay, so this was a big finding. It was before the 50s, I think 20s, 1920s or something like that. Okay. Now, Q of system, so we're going to take that, we're going to assume that that is true. See, they say it in one statement, but you can write a whole book about how they came about with this equation, okay? Let me make sure we are recording, so. Yeah. So then we can write delta S surroundings is minus delta H system over T. The enthalpy change is simply the enthalpy change for the reaction. So at this level, we're just going to assume that this is true. They're going to give us a little bit of explanation on the next slide about why we have T on the bottom. No questions so far?
I have one.
Yeah.
Is there like a reason why the enthalpy has to be negative? Or is it just because at the end?
Because we have surroundings and system, right? So remember Q of, what was that? If you had this reaction, how it reacted with the solution, you remember that? Q of reaction equals minus Q of surroundings or solution. Do you remember that part from last year, last
Yeah,
semester?
yeah.
Because the sum of the energy should be 0, because heat is neither created nor lost. So when I lose some energy, when I have hot coffee and it's no longer hot, when the steam goes away, this is losing energy, right? Heat. But the surroundings is picking up the heat. So I'm not making any new stuff. Neither is the surroundings gaining anything that is absolutely new. It's just an exchange.
Okay. Yeah, that makes sense.
That
I
makes
have,
some
I have
sense.
a question.
Yeah. Who's that?
Are Q
Kennedy?
and delta H interchangeable?
Oh, which one? Q and delta H, yes. Now, when are
Yes,
they
that's me.
interchangeable?
Are, yeah,
QP
okay.
is delta H. What does QP, what does that P mean?
System.
Huh?
Is it the system?
PP. Capital P,
Pressure?
yes. When you have Q changes at constant pressure, like in your lab, then that is equal to delta H. Got that? Kennedy, is that helpful? Oh, there are two
Yes.
chat messages. Okay. Let's look at that. F12 to I cannot show. Okay. Oh yeah, Tom has a class from 12 to 1:30 on Tuesday. Will, I'll have to talk to you at the end, okay? Because we discussed a lot of that about the test at the beginning, but I'll be happy to do it at the end as well. So, well, we'll see about the timing. If nothing else works, we'll have to meet at 9:30 on Tuesday. Oh, Ashani, we'll see. So Q at constant pressure. That's what is equal to delta H. So when you talk about enthalpy, that's usually at constant pressure. Okay. So they're saying, why that delta, why that T on the bottom? Okay. They'll give you an explanation, and it may be a little too much at this point in time. So they're saying, and it's understood, right? Delta S surroundings is inversely proportional to 1/T. Okay. Is inversely proportional to 1/T. So when you have low T, that's all we're going to look at here. When temperature is low, what happens to delta S surroundings? Temperature is low. Delta S surroundings will be?
Increase.
Yes. As, I'm just going to say this, as T decreases, very good. Decreases.
Dr. Mary,
Yes.
where can we see that?
What do you mean?
Like, what's an example of the surrounding increase? Never mind. Never mind.
Why do you say never mind?
Because I just thought about the example that you just gave us, and that's like as the temperature, like in the coffee, decreases, the surrounding is gonna like increase.
As T decreases. Okay, so
Yeah.
let me say that's more like delta H. Well, we'll see. Well, that's delta S surroundings is related to delta H also. So they're saying, let's say you have your particles like that. Okay. Let's say this is at 30 degrees centigrade. And then when you decrease that to 10 degrees centigrade, there are other changes taking place. What they're saying is, which one will have more kinetic energy? The one we're comparing kinetic energy. Which one will have more kinetic energy? The one at 30 or the one at 10?
The one at 30.
30, right? Okay. Now, to this, you see your delta H system? This is pumping in energy from the outside. Okay, this is your surroundings, remember. This is your system. When heat comes in, who's going to be more excited? Who's going to be more excited, or who's going to be dispersed more? They're saying this guy is going to be more dispersed. PChem is a whole lot of fun. So it's like I have $10 and you have $30. If somebody gives me $10 more and they give you $10 more, who'll be more excited? They are saying the poorer guy will be more excited, or they'll be more, dispersed with the little heat that comes in, or the change that they see is more for the 10 degrees centigrade than for the 30 degree centigrade. So that's why they say as T decreases, delta S surroundings increases when you have heat coming in from the system. Not that? Okay. One person understands and the others?
I understand.
Okay.
I understand too.
Okay, great. Thank you, guys. Because I'm such a great, never mind, I'm just teasing myself. How are y'all doing? How are y'all holding up? Are y'all okay? Not with my class, but in general.
I think we're doing okay, or I'm doing okay.
You're doing okay?
Too. Yeah,
Elma,
I'm doing good.
are you cooking new recipes, Elma?
Yeah. No, I've been making more coffee recipes.
Yeah. The coffee shops in town are, a lot of them are closed, so I make my own coffee too.
I'm becoming a new barista.
Barista, yeah. I'm sure the perk will have jobs in the fall. Yeah. Anybody else trying new stuff? New way of learning. Mr. Tom Smith, you know what? I was trying to send Tom Smith an email about last week's Q&A session, like telling him he can come. I was in the middle of the night. And I picked Tom Smith. And the next day, Dr. Tom Smith, the athletic director, he's responding and saying, "What Zoom session are you talking about?" Like, oops, sorry. So, Tom, you got me in trouble. And so that's how it went. Tom, are you working at Amazon? Tom's taking a break.
I work at Walmart.
Oh, you're working at Walmart. Are you still working the same hours?
Yeah, it's usually about 50 a week.
50 a week. Okay, wow. Yeah. Well, I have a question. So if y'all, do you have to be a full-time employee to get the stimulus package, or even part-timers, will they get it? How does it work? As students, if you work outside, do y'all still get the stimulus package?
I don't think we do, because if you're a dependent, you can't be a dependent of your parents, I don't think. You have to file individually. And since we're above 17, we don't qualify as a child either.
Yeah. So you don't get the 500. The family doesn't get the 500. So you're not covered either way. Is that what you're saying?
From a few things I read online, that's what it looks like.
Okay. Well, Trump needs to change that a little bit. Because you guys have car payments, you have rent to pay. Somebody's chatting. Students and parents do not get anything. Students and the parents of students do not get anything. Okay. Oh. If you're a college student. Okay. All right. What time is it? I'm going to go to 11. So high temperature, ST increases. Delta S surroundings decreases. Okay, that's why they saw this to be true, and therefore they came up with these equations. Okay, so when you all become scientists and you want to come up with your own equations, right, Kevin? Kevin Rodriguez equation. And then, so you observe, right? Scientific method. You make observations, and then you test it over and over again. And then when it's true, that becomes a law. All right, moving on. So that's more for the conceptual part, and also like understanding why we use it, because we'll be using it quite a bit. Let me make sure that I am on the right page. I think so. You might need the table, you know, that I asked you to refer to. Thermal tables on Canvas. They didn't let me print that, so I had to give a link. Or it printed one page out of the 5 pages. Okay. Calculate delta S surroundings and delta S universe. And remember, I'm just going to make it short. Delta S cis plus delta S surroundings. Okay. So they're assuming you know how to calculate delta S system. Let's write the equation. Reaction of hydrogen and oxygen. Can you write the formula? You'll still remember? And it says 2 moles of water. And again, gas. These phases are very important, because the values may be different. Now, let's first calculate delta S surroundings. We don't have a table that gives you S surroundings values, but we have this equation. Now you know why we need that equation. Because we know how to calculate delta H system. We might have forgotten a little bit, but we did learn it. Now go to the table And I'm going to give you an equation here. Delta SH0 reaction. Let me write it here. We're also making the assumption that that is equal to delta H0 reaction, which we can calculate using the table. Now let me point out, if I may, you see the table, or am I not sharing yet? Okay. I'm sharing now. So you see chapter 18? These are the notes that I'm using. These are the notes that have all the answers and everything that you need. And click on the thermal table, please. This is in your interactive textbook. It didn't let me print the whole thing, so I'll have to do something different on the test. But that's where it is, okay? So I'm going to stop that and go back to the document. Now, do you remember this? 2 moles of water times delta HF0 for water gas. Are you remembering this? Products minus reactants. 1 mole of H2 multiplied by delta HF0 for H2 gas plus 1 mole times delta HF0 for O2 gas. Lots of brackets. What does this 0 mean? Delta, I keep saying delta HF0. 2 questions. What does that 0 mean? And what does F mean? You'll remember? I put a 0 there as well. This means standard state conditions. This is usually 25 degrees centigrade and 1 atm for thermodynamic variables. We did STP for gases, but there the standard temperature was 0. Okay, so for gas laws, it's 0. For thermodynamic properties, parameters, it's 25 degrees. What does the F stand for? Heat of formation. You'd have to review from thermochemistry, okay? You have to see how we got those values and things like that. We discussed all of it. Now, can you get delta HF0 values from your table? Can you all substitute? What is delta HF? I'm going to make you all look it up like we do in class. Can you find the delta HF values from the table and give me an answer? What is delta HF0 for hydrogen?
Hmm.
What is delta HF0 for water, gas, minus two, what was that?
Minus 241.8.
Kilojoules per mole.
Yes, ma'am.
All right. And then minus 1 mole. What is delta HF0 for hydrogen?
Just 0.
Why is it 0?
It's the natural form.
It's in its natural form. That is 0. Okay. This is hydrogen gas. This is 0 for oxygen gas. It's in its natural form. It was created, so we don't worry about how much it costs to create that. So the answer is simply 2 times 241.8 kilojoules. Okay, write that down, minus 483.6 kilojoules. We will need it later, so write it down. Okay. Now we've only gotten delta H0 reaction or delta H system, okay? We haven't actually calculated delta S surroundings. So can you calculate delta S surroundings? What's the equation?
That divided by temperature.
Negative of that, divided by capital T, which is Kelvin. So negative of negative 483.6. These calculations are not difficult at all. You just have to be careful with the signs and formulas. Okay. Now, for some reason, they want this in joules. So can you give me an answer? Usually, delta S is given as joules. They're smaller than the normal delta H values.
So it's 1622.
Okay, let's do 3 sig figs.
16662 times 10 to the
Third.
Yeah.
Okay. Everybody get that? And that reminds me, for the test, for this one, you will not be using the quadratic formula. So all of you must use the simplified version. Okay, I was just reminded about that. So you don't need the quadratic formula on your phones. You will not be using that. So make sure that you clear off all the formulas on your phones before you take the test. Okay, so we only found delta S surroundings.
I didn't get that answer.
Did you convert kilojoules to joules?
Nope, and that is why. Thank you.
Okay. Can you look back in your notes from last week? Can you give me a value for delta S system? We did that in the previous section. Can you go back and look at it, find it, and see how you calculated delta S system for the same equation? Or should we just go ahead and calculate it again? We have delta S surroundings. We need delta S system. You would have done the same thing, 2 moles times S0 for water, gas.
It is
Minus.
negative 89.0.
What is it?
Negative 89.0 joules.
89, right?
Yes, 89.0 joules over Kelvin, I think.
Yeah, you're right. Plus S0 for H2 gas. I'm going to do it this way. I'm going to put the negative sign before every reactant. It's less confusing. S0 for oxygen and gas. You see that? I put the negative signs. It's less confusing. Now, S0 values, whether it's an element or a compound, it has a value. Now, you may want to insert all the values. And the last time when we did this, we got negative 89.0 joule per Kelvin. What is delta S universe then? Do you get a positive value for delta S universe? Do you get a negative value? If it is positive, because this is negative, right? Delta S surroundings, though, is larger than delta S system. See that? So is this reaction, if I gave you hydrogen gas in a tank and oxygen gas, oh, that'll be deadly, because it'll be, it'll give you a lot of, what's delta H here? You see that it's exothermic. You see that? And especially if you have hydrogen coming out of a tank, it's under pressure. So this reaction, if you have pure hydrogen and pure oxygen, or even if you, if there's a hydrogen gas leak from a tank, that reaction is quite powerful. And it's spontaneous. How do you know that? How do you know this reaction is spontaneous?
It has a positive value.
Because it is positive. What's the second law of thermodynamics? What's the second law of thermodynamics? This reaction is spontaneous when delta S universe is positive. Okay. So as long as you know the formula correctly and you write down the equations correctly, you're not going to go wrong. I actually wanted to finish this section, but looks like we'll not be able to get to it. From next week, after we finish our exams and all that, we're going to be ramping up, all right, until we get ready for the next exam. And I want to do some problem solving sessions as well. I want to get to electrochem because your next lab after this week will be, not next week, but the week after will be electrochem. That'll be the last lab. So I want to start the theory for that so you can do the lab. So I'm going to stop here because it's 11 and I have a class starting at 12 and some of you have classes as well. Now, if you missed the first part, I have in the recordings at the beginning, you will see that I've divided up our exam 3 into 2 parts. The first part is Thursday at 1:30, Zoom with numerical tables, which means you'll be on the video like this. I should see all of your heads. And if there's a problem, you'll have to let me know ahead of time. And the titration tables and the ice tables, I'll like, you know, create little templates even for the ice table and give it to you ahead of time. And I'll let you know how many you should print. And then at the beginning, you will show me your desk area and show me that you put your phone away and all the materials away. Just your clean calculator, and you will not be drawing any graphs. And then we'll all start the exam at the same time. So the questions will be visible to you, like how I have this on the screen, it'll be visible to you. I'll try to put it all together in one page because if I don't leave room for work, then the problems are going to, you know, not need too much space. But if you need to, you can print it out and have it. But I don't think it's necessary. And you will write your answer. And you will have to label the problem number so I know which one you are working on. And be legible. And you'll upload it. And when you finish the test, you let me know that you're done. And then what did I say? Yes, when you're done, you will let me know through the chat, you know, and then, or you can raise your hand and say, I'm done. And then I'll let you bring your phone or whatever. And then you can print it, scan or phone. Okay, I want to see you do that. And then you will upload it on a link that will become available, you know, for the time period of the test. And then it'll be done. Okay, so somebody is asking about printing. Now, you don't have to print the tables I send you. You can just make your own tables. I'll have to look at all the materials you have before you start the test. So you can draw your own tables, okay? You don't have to print anything that I send you. And that's why I'm saying you can write, you don't even have to print the questions that I'm sending you. So you can just draw the table if you wanted to, okay? But you have to do that ahead of time and keep it ready, and you have to show me before you start the test. So no printing is required. And you've all been scanning. Your phone should have a scanner, and you've all been doing it, so there's no problem at all. Okay. And like Ka values, that'll be given with the problem. Let's say I'm doing acetic acid for a problem. I'll give you the Ka value, so you don't need anything else. Does it help? I think. This test on Thursday is not via Canvas. You have to write the answers, scan, and upload. Does it make sense? Okay.
Yes, ma'am, it makes sense. Thank you.
But when will the questions be available to be printed copy by hand? The questions will become available after I check all your desks and your know that you're prepared. And that's when I will post it on the screen like this. And you will do one question at a time. And I'm trying to make sure that it fills up just one screen. But if it needs to go on another screen for some reason, then you can tell me, you know, can you move the screen, and I'll move it for you. Okay? Does that help?
Yes, that does.
Okay, so you will all see the questions at the same time after I make sure that everybody's ready. Yes, you can do it on loose leaf, but can you do it on a nice sheet of paper if you can, like a printer paper, you know, or if you have ruled paper, but be legible. Otherwise, I'll take off points. The tables probably today. I can have the tables available, you know. Give me some time. I'm saying today. I'll try today or at least tomorrow by afternoon, so you can all print those beforehand. Okay. And then also the test on Monday, we'll have to talk about it. I'll be like planning that. But the test on Monday will start at 2, and that'll be a lockdown browser, limited time, and you will have to use Math Editor for some of the problems. Unless you show me some work, some equation, some work, I'm not going to give you points, even if the answer is perfectly correct, just like on a test. All right. So, so we'll concentrate on this one. And then Monday at 2 is when I'm planning to do the other one. And then question and answer, you know, I know you may have last minute questions. You can email me before, but I'm trying to do a Zoom session for Q&A Thursday at 11. And these are the sections you have to review for the test. And work on your sapling. Don't wait till the last minute, and try to learn when you do your practice. And that practice alone is not sufficient. You should start with your lecture notes, gather them up wherever they are. Hope you're taking good notes. I'm not able to, you know, go to school and scan the whole thing that I'm writing on. My scanner will scan one page at a time, so it'll take forever. But the recordings, you know, I will be posting right after we are done. And if I go to campus, I may have to get a couple of folders or something, then I'll do it for you. Any questions?
No, ma'am.
Okay. So if I don't find another time, because Tom has a class at 12. Tom, are you done by 1-ish usually?
Yeah, he's usually done by around then.
1, okay. So if we did.
I mean, if it works for everyone else, I could just watch the second half of the recording of it. If it works for everyone else.
Yeah, 11 to 1. Yeah. Okay. We'll see. How about if we did 1:30 to, I know Jessica has a class at 3:30, Jessica?
Yeah.
3:30. How far do you have to drive? Just kidding. So we can go from 1:15 to 3:15. Any problems with that time?
No.
All in favor, say. Will, do you have a problem? Can you post all of this on Canvas? I'm recording all of this, Brandon, so you should be able to review that. And also the sheet, the information on this sheet, I will post. Okay, with more details, I'll be posting that. Yes.
So we're doing 11 to 1 on Tuesdays and then 1:15 to 3:15 on Thursdays.
No. Oh, that's what Brandon wanted, the timings. Sorry, Brandon. We're talking about timings. Let me get a fresh sheet of paper. So schedule for next week. Monday, 2 to 3. Exam 3, part 2. Okay. Tuesday, will 1:15 to 3:15 for lecture work. Because Jessica has a class at 3:30 and Tom has a class till 1:15. If it doesn't work, raise your hand because I'm supposed to take attendance.
That time won't work for me.
Who's that?
Bailey.
Bailey. When are you available? Tuesday afternoon?
I won't be available Tuesday afternoons because I work afternoons.
From 1 o'clock?
Yeah, I go in about 1:30.
Oh, okay, okay. Tom may miss the last part, but it's recorded. How about that, Tom?
That works.
Okay, sorry about that. I'll try to do a lot, before you have to leave. At the beginning. Everybody else okay? Okay. Now, Thursday, we do not have a problem, I think. I wanted to do 2 hours, so that covers for, the 3 sessions that we meet. Everybody okay with Thursday, 1:30 to 3:30? Okay. And then I'll be there at 1 and I'll be there after, if you have questions. So, and like I said, we'd have to, by Thursday, I'll start electrochem, all right? And then I want time for problem solving too, like how we do in class. So, Will, the test on, do you have this? I'll post all of this on Canvas as well. The test on Monday at 2 will be only on Canvas, and you don't have to download anything. You'll do all of your work on Canvas, and if numerical work should be shown, I'll make it an essay question, and you'll have to use Math Editor. And you can give explanations. And then when you're done on Canvas, you're done. Okay. But remember, you'll not have a whole lot of time, so you have to be prepared for it. Okay. Everybody good?
Dr. Mary, will you stay on after everyone leaves so I can ask you a question?
Yeah, sure.
Okay.
Yeah, I don't have to be done till, I have time till 11:30. I just have to get ready for the other class. So bye guys, take care, study, email me, and I'll see you at the Q&A on Thursday 11 if you want to be there. Otherwise, I'll see you a little before 1:30 on Thursday. Okay.
Have a good day, Dr. Mary.
Thanks, y'all too. Bye.
Bye, Dr. Mary.
Take care. Love you guys.
Bye.
Bye. Bye. Bye, Kevin. Bye. Kinsey, bye. Will, did I answer your questions? And you can always call me, Will. If you email me, I can. Yes, you did. How's it going to work with my extra time? Yeah, we'll talk about that. Okay. We'll talk about that. Would you prefer, is it okay, Will, if I talked with Kennedy here?
My question is just a question about the actual lecture, so it's nothing personal or anything. I just
Okay.
didn't want to keep everybody.
Yeah.
Will you
Go
just
ahead.
show the last slide
Oh,
that you worked on? I was in the bathroom and I didn't get to hear or see it.
okay. Yeah. Will, I'll give you my number, okay? Good. Don't sell it on the market. Which one is it, Kennedy?
Just the very last one where you did, I got up to the 2 moles of water and we found the kilojoules, or we found the joules over Kelvin.
Okay.
And then you moved on, and then it looks like, because Jessica sent me the slide, it looks like you broke up the water reaction and then looked for the S0 numbers on the table. Yeah.
Is this the slide?
Yeah, that's it.
That's it? Okay.
So where did the S0 come from? I know they're on the tables, but why do we do that?
Okay, so yeah, good question. Remember when you do delta H0 reaction, you have this equation, right?
Yes, I got that, yes.
So just like that, let me pull that slide that we used. It's from last Thursday. Are you able to find the slide?
I don't follow along with the slides. I write everything down.
Down, okay. I thought we did a problem. I mean, what's his name was able to find it, so I must have done it. I'll find it. I have papers all over.
It's okay.
So you remember we used this table?
Yeah.
Okay. And then we did this problem.
Oh,
Remember?
okay.
I just redid
Okay.
that whole thing.
Yes.
Yeah.
Oh,
So-
okay.
This is a different problem, but I think we did one for the water reaction.
Oh, I thought it was like a continuation of the problem we did above it.
Yeah. Okay, I see.
Oh, because isn't it that?
Mhm.
Okay, because it looks like that you solved for the delta S system and then used that and plugged it in to find the delta S universe. Is that right?
Yeah. So then what I did was, yeah, delta S0 reaction is the same as this.
Okay.
And then I found delta S here on the slide. We found delta S surroundings on the
Surroundings.
previous slide. And then we add
Okay,
up
okay.
to.
Okay, but my only thing is when I did it, because I did like the top part, I didn't get -89. I got -74.5.
Did you use water gas? Instead of, if you use water liquid, it gives you a different value.
I thought I used water gas, but I can try it again and I can just email you. It's not that big of a deal.
No, I have. Let me, because I have it written down from the other day. So do you have these numbers? Do you have
Let me
188?
look. I did. Oh no, I didn't. I did 205. So did I do the wrong one?
Yeah, that must be water for liquid or something. Oh, 205 is here. That's for oxygen.
Oh, okay. 2 moles of 188. Oh yeah. Hold on. What's that? What's the 188 for?
188 is for water gas. S0.
Oh yeah. Oh, okay. I forgot to. Okay, I didn't calculate that into it. Okay. Okay, I got it.
Okay.
Okay, and do you still want to test that something at 3?
Yes. So what I want to do, nobody's here. Well, it doesn't matter even if they're there. With the Zoom, I
Mhm.
want to try the lockdown browser.
Okay.
So I need to set up another quiz or and then
Okay.
I'll see if I can make it available just to you for that time period. And
Okay.
some are saying they don't know, and they said the best thing is to. So when you are doing the lockdown browser, I'm around, to ask questions and, make sure
Right.
it's going okay. So that's why.
Okay.
So
Okay, yeah, I can do that. Just text me.
I'll text you when after I have the quiz ready and after I've set up the Zoom, I'll text you. Okay.
Okay. Okay, that sounds good.
All right. Thank you so much.
All right, no problem. Bye-bye.
Bye.